Okay, so here's a typical curve sketching, no calculator question, where you're given a function that you probably don't know what it looks like, and you need to sketch it showing, and the instructions say you have to clearly show and classify all the stationary points. Okay, so the first thing we would need to do here, unless you're instructed otherwise, is to find the zeros of this. Like, where does it cut the x-axis? So to do that, I make the whole thing equal to 0. And I'm going to want to factor to do this, right? It's always the step you want to do when you want to find the x-intercept. So it's got x cubed is a common factor. I'm actually going to take out minus x cubed out the front, and that's going to give me times x. That would give me negative x to the power 4, and then minus 4. Negative x cubed times minus 4 would give me positive x cubed. So this is going to give me x is equal to 0. So I know that 0, 0. I knew that anyway because there was no, because it's plus 0 up here in my function. But it's good to find it anyway doing it this way. So definitely 0 is one of my points. And if I make x minus 4 equal to 0, then x is equal to 4. So my graph is going to be, like, it's going to have an x-intercept, like something like that, at 4. Okay, so that's the information that I know just from looking at my original graph. Okay, now to go any further, I'm going to need to take the derivative. So let's do that now. F dash x is equal to negative 4x cubed plus 12x squared. Okay, so once again, the next step here is to make this equal to 0 and find the roots of this. So I'm going to need to factor again. I'm going to take out negative 4x squared, and that gives me times x minus 3. So my values, my important values, my stationary points for my derivative are x equals 0 and x is equal to positive 3. Okay, so what I want to do this is to start making a sign chart. So I'm going to start my sign chart up here, I think. And the values that I need are 0 and 3. And I want to look at f dashed x. Okay. So obviously I know that at 0 and at 3 I have zeros here. So now what I want to do is substitute back into my derivative and work out what the signs are on each side of my 0. So if I choose a number less than 0, I'm going to choose negative 1. Well, because it's cubed, it's still going to be negative 1. Times 4 is negative 4. And then it's going to be positive 4. And then my negative 1 is going to become positive, and times 12. So actually it's going to be positive on this side of my 0. Okay, I'm going to choose negative 1 now for the value between 0 and 3. So positive 1 times, this is going to be negative 4 plus 12. It's still going to be positive. And then I'm going to choose a much larger number, let's say 10 to the right of 3. So 10 cubed is 1,000 times -4 is -4,000, and then this would be plus 1,200. So it's actually the negative is the larger value, so that's going to be negative there. Okay, so I have my first derivative sign chart, and now I'm going to, and it looks like I have some sort of inflection and maybe a maximum. Okay, let's just find out though. To find out for sure, we need to look at the second derivative. So let's take the second derivative, and that is going to be negative 12x squared plus 24x. Same process, I want to make this equal to 0 so I can find my stationary points, and I'm going to factor out minus 12x, which gives me x. No, it's not going to be plus, it's going to be minus 2. Okay, so x is equal to, once again, x is equal to 0, and x is equal to positive 2. Okay, so I'm just going to do a little bit of erasing here, just to give me a little bit of room. Okay, and here is going to be my double derivative for my sign chart. Now, I have to put in a new value here, 2, and obviously I know that this is 0 at the 0, and at 2 it's 0 as well. Okay, so I'm looking to see what the signs are on either sides of the 0, and I'm substituting. So I'm substituting into the derivative function, second derivative function. So I'm going to choose x is equal to negative 1. It's going to become, so negative 1 is going to become positive 1 when it's squared times 12. It's positive 12, it becomes negative 12, and then it's plus negative 24. So it's going to be negative on that side. Okay, so I want a number between 0 and 2. That's going to be, I'm going to choose 1, positive 1. So I'm going to have negative 12 plus 24. So that's going to be positive. And then just any number to the right of 2. So once again, I'm just going to choose 10. So I'm going to have minus 1200 plus 240. So my bigger sign is negative. Okay, so there's my sign charts worked out. Okay, so what I can do now, I'm just going to do a little bit more erasing so it's a little bit easier to see what happens here. Okay, so if I look at my first derivative, what it suggests is that my graph has an increasing slope, and then it's 0, and then it increases again until it gets to 3, where it's 0, and then it's going to come down. So it looks like some sort of inflection and a maximum. If I look at my second derivative, I'm just going to erase this as well actually. If I look at my second derivative, then what it's telling me is that my concavity is down, which means that the shape of the graph there is kind of this shape, right? Then I have a 0, and then my shape of my concavity is positive concavity, and my shape of my graph is up like that. And then over here, my concavity is down again, it's concave down, and it looks like that. Now, the other thing that we can see here is I have an inflection. So I know that I have an inflection. It is at x equals 0, and I know it's an inflection because I have a sign change at f double dashed x, and it's 0 at f double dashed x as well. Now, because it's a 0 here as well, I know that this inflection here, the one at 0, has to be a stationary inflection, right? So I can tell from what I can see so far that my graph is going to come up. It's going to have, it's going to be concave down. It's going to come up to here. And then what happens? Okay, what happens then is that I have, is that my curve has to, so the part that I've already drawn, this part here, is my concave down part. That's this part here, right? The next part is going to be concave up, and that is going to, it's going to be concave up until I get to x is equal to 2. So if I make 2 here, what's going to happen is my shape of my curve is going to change until I get to x is equal to 2. So there, I've just drawn my concave up part. Now, okay, here's the interesting thing, is I have another inflection here. So remember, I know it's an inflection because I've got a 0 on my second derivative and I have a sign change. So I also have an inflection at x is equal to 2. But this time, there's no corresponding 0 up here on my first derivative, so this inflection is a non-stationary inflection, and all it represents is the change in my concavity. So my curve is going to go from concave up at this point to concave down, and it's going to do that until the curve reaches 3. So it's going to come up like this until we get to 3, where it's clearly a maximum, and then the curve is just going to come down and pass through that x-intercept at x is equal to 4. So I have, if I draw my concavity arrows here, I've got concave down here, concave up here, concave down for the entire rest of the graph. And I have my first stationary point was this one here. It was a horizontal inflection, and I know that because I have a 0 here, a 0 here, and a change in sign. My second inflection point was at x is equal to 2. That was a non-stationary inflection point, but I had a 0 in my second derivative and a sign change. I know it's not stationary because there was no corresponding 0 on the first derivative. And then finally, the last stationary point is that x is equal to 3, which is my maximum, and I can tell it's a maximum because it's concave down.